In Minecraft, there's this stuff known as redstone. Redstone follows some basic rules for powering blocks. The powered block can be thought of like a logic high. An unpowered block is like a logic low. And I won't go into the details, but redstone can be used to construct all kinds of digital logic circuits. I've already constructed the full adder and the data bus connecting to it, as well as the inputs. And I've started adding the other functions, the OR function, the AND function. Now this ALU is a little different from other ones in that it can be extended with as many functions as you want to. All you have to do is extend the data bus out and add another function next to the three existing functions. The output of each function is run into a very large mux that basically chooses which function to output by using tri-state gates and OR gates. So this is my ALU, and I'm going to go through a few of the basic functions. And so here we have our inputs of A0 through A7, B0 through B7, and our outputs, which is C0 through C7. We also have a carryout. And then we have some other control signals here. So we can invert A and B, and we can also set the carry in on the full adder. And then to select our output, we simply enable one of these functions. So we can choose between the adder, or the AND function, or the OR function. So let's add some numbers. So we add 1 to 0, and 1 appears on the output. We add 1 to 2, you get 3. So if you add 1 to 3, you get 4. Now we're going to add some large numbers to see the function of the carryout. So if we add 1 to all 1s, and we just get 1 on the carryout and all 0s. And then if we enable the carry-in signal, just adds 1 more, and C0 will light up. Turn that back up. So if we want to test the invert functionality, simply do that, and now all of the all the A inputs are now inverted. So we're adding all 1s and all 1s, and we get the result. And then carry in, add 1 more, and then you get all 1s as expected. So our other functions include an AND and an OR. And so to enable one of those, we turn that one off, turn that one on. And then we'll get the output that we expect. And all 0s and all 1s ANDed together. So whenever we enable one of these, the one above should light up after a short delay. And then we can test the OR function as well. We turn them off, and the output turns off. And they're all ORed together. Alright. So let's go through the design a little bit. This is basically the input and the output. And everything is run levers, so you can control the input, and the output is just run over here. This blue leads up to an XOR gate, and the XOR gate is basically what inverts the signal. and then the white part delivers the signal to the data buses. It's basically two data buses stacked on top of each other, and each function, you can see the different colors, reaches into the bus and connects to the controller for the lines for the function. And the data on the bus is actually inverted, and it has to be inverted and put on the bus and then inverted again to get off the bus to get the right values. So this purple here is the OR gate, and the green here is an AND gate, and this blue and slightly different blue color is the full adder. This is a ripple adder, and basically the carry out connects to the one next to it via torches, redstone torches, you can see them in there. And then the final one's carry out is delivered to the output bus. And the blue part here is one XOR gate, which connects to another XOR gate, and then the AND gate on the side is what does the carry out. All of these signals are delivered to a MUX. The MUX is built using pistons that function as a tri-state buffer, and they control the bus output along with the OR gates. All of the outputs are ORed together with a 3-input OR gate, and then inverted and put on a bus. And then inverted again to get off the bus. And this is done like this because on our inputs, the least significant bit is on the right, and then coming out of the output, the least significant bit will be on the left. So we have to crisscross all of the bus lines to get the output ordered in the right way. And that's all. Thank you for watching, and thank you to Hat Films for the music.